how. And I will pass this over to Aniket to take us through the webinar.
Thank you very much, Duncan, for that introduction. As Duncan mentioned, my name is Aniket Devecha. I'm the Assistant Sales Manager for Analytics. And our today's webinar will cover our Xelsius technology, which is essentially a 10-in-1 reactor block solution for heating, cooling, more for synthesis-based application. Before we do get into the actual Xelsius technology, I'll just quickly cover in terms of who actually Analytics are, what we do, and what we can offer to your laboratories and organizations. Analytics, we're a provider of sample preparation technology. We've been around for over somewhat 25 years now, based in Bolton, which is northeast of the UK. From here on, a lot of our technologies are based on improving your workflow, streamlining your sample preparation process, and essentially offering more safer and productive platforms to improve your research capabilities. Our background purely relies on reducing the chemical consumption, whether that's either via acid usage, solvent usage, and a lot of our innovative techniques that can help your laboratory in terms of moving forward. We supply microwave technology, so these are used for acid digestion applications, solvent extraction, or even microwave synthesis if you are looking to scale up. But the pure reason of microwaves is it reduces energy, is faster, and of course you get a greater control in terms of temperature, power, and pressure parameters as well. The other thing we can offer to you is analytical pyrolysis. So again, a technique used to extract organic pollutants, whether that's polymers, whether that's sort of environmental sample matrices. Essentially, it's a no solvent usage techniques used to identify and characterize your organic compounds. We also offer direct mercury analyzers. So these are dedicated mercury analysis systems, which essentially can give you results in 6 minutes. And again, there is no sample preparation required. So we're saving on time, we're saving on acid digestion, we're saving on, energy side of things as well. Micro GC, we represent Agilent as well, purely for their portable 990 Micro GC system. I mean, these are fast portable gas analyzers, purely dedicated, for gas analysis based application. Again, due to its portability, the savings in terms of compared to a general benchtop GC, there is a lot of savings on the gas consumption side of things as well. So in terms of Xelsius, which is the main topic for today, really, I mean, Xelsius, what is Xelsius? So Xelsius is our compact 10-in-1 reactor solution. So essentially you have 10 individual reactor cells, all controlled independently from each other. The temperatures can vary from -20 to plus 150. So essentially you can have 10 complete temperature profiles in each of these reaction cells. Now, what you see on that picture there, essentially you have two modules. One which is the actual the hub of the system, so the more the PC, the controller module, and the second one which is where the individual reactor cells would sit. And on the background is a Windows-based tablet, which is again used to control each and every individual cells. I mean, throughout the presentations, we'll be referring back to the sort of the screen on the software, where it gives you a bit more of an idea in terms of what the parameters can be. In terms of the technical specifications, again, as I mentioned, there are two modules. Each is 36 centimeters by 16 centimeters. So 36 is obviously the length. I mean, it's got a very fast and a very accurate temperature control as well. So the heating rate, as you can see, is 48 degrees per minute. And the cooling rate is 36 with a very accuracy in terms of 0.1 degrees as well. You can have stirring in each every individual vessels, all controllable with the rates of 350 to about 1500 RPM. And we typically work with volumes and vessel sizes between 1 to 30. I mean, we've got two main ones. One is 5 ml, and the other one is 30 ml. So if you're working at the lower end, to avoid any spaces or any sort of overheat, we recommend the 5 mil. But then if you are working on the slightly larger scale, then obviously the 30 mil is what we would recommend for you. In terms of control, each of these individual cells is all Peltier module. So each and every of these cells can be controlled either via an infrared sensor, which is already in the system built in, or at the back, as you can see on that photo, there is a opportunity to put in an external temperature probe as well. So this obviously goes to say that if you wanted more of a in reaction temperature, then probably the external temperature probe is a way forward for yourself. There is also a chiller accessory, which obviously controls the Peltier cooling side of things. So it's an external chiller, which is just kept on the floor right next to the system. And there's also an opportunity for purging as well, if you wanted to do condensation type of reactions as well. As I mentioned at the start of the presentation, the software, in essence, this would be the main screen. Now, each and every of these cells, as you can see, it will have its individual numbers. On the left-hand side of the screen, you have the odd numbers, so cell 1, 3, 5, 7, 9. And on the right-hand side, you've got the even numbers, which is 2, 4, 6, 8, and 10. Again, all of these are managed, controlled very independently. Of course, you can replicate the programs into every cells as you deem fit. You can essentially do as you please to manage your reactions. And this is where the beauty of Xelsius is. I mean, this is a typical profile where you've got a start, heat, hold, and a cool, and an end profile. And in the middle, as you can see, you can repeat this cycle several times. I mean, there is no set limit on this, but this application comes in very handy if you're looking to do any crystallization kind of work or even general synthesis. But essentially, it's pretty much each window would you can have a different temperature profile within the Xelsius system. In terms of its accessories, there is a reflux condenser block which sits on top of it. Again, it's pretty much just place on it. So there is no real external attachments or anything like that. So if you are working, you want to prevent any loss of boiling solvents or these kind of application, essentially there is possibility to reflux. There are other accessories as well, which is inertization if you're working to do with inert gases, filtration. So several options are available as well. The other accessories is the caps, which are available for the profile. There is a 5-port cap. I mean, this obviously allows you to do any inert gas studies, to take some sample out via syringe, that kind of thing, inject any purge gases in. So, I mean, essentially, it allows you to do and mimic flow chemistry in inert atmosphere, multi-stage. So the 5-port cap would allow you to do direct temperature reading, inert atmosphere, gas bubbling if need to be, sampling, and of course, flow chemistry, these kind of application as well. We've also got our automated dosing station. I mean, obviously, this doses the solvents automatically. There is an automated sampling, but this is obviously an external piece of kit, depending on your application, what you're looking to do. But there are obviously options for dosing as well. In terms of applications, I mean, where we found a lot of the applications is, of course, in the parallel synthesis, reaction optimization. Drug discovery has been a huge, especially within the pharma sector, crystallizations. But essentially, the beauty of Xelsius is it's not limited just for one application. Essentially, where you've got 10 individual reactor cells, that gives a true flexibility where you can essentially perform several different applications practically using one platform. And it's not just the benefit of having the sort of the technique and the benefit of having the technology solution, but there are, of course, further benefits in terms of savings, which I'll be going into in a few slides. There are also, we are currently working on some exciting new accessories and future applications. So one of which is photochemistry probe, which again is due to be released in the future. We've got turbidity for solubility studies. That's again in the pipeline. already. And like I said at the start, that with Xelsius, it's not a case of it is a maintenance-free instrument as well. So not much goes wrong in it. Just depends on application, what you're looking to do. And again, you have 10 heating cells, individual magnetic stirrers, which is replacing all your ice baths, refluxes in the fume cupboard, and essentially is bringing all into one as well. So when we discuss the conventional synthesis type of platform, whether that's hot plates, stirring plates, water baths, of course, one of the biggest thing is space. Now with Xelsius, of course, having just one instrument is saving a lot of valuable laboratory space from that side as well. Essentially, you've got one unit in one instead of that. So the classic approach where you might have some heating cells or ice baths or stirrers, typically footprint is done by approximately just under 3 square meters. However, as you can see, the footprint of Xelsius is a fraction of that, and saving you, of course, on the maintenance of the fume cupboard as well moving forward. We've also done some energy calculations. I mean, this is just on a rough estimate. However, we can obviously narrow it down on your individual requirements on a case-by-case basis. Of course, you've got the fume cupboard, which is 1.8 kilowatts per hour. As you can see, we're using just over 10,000 kilowatts over 12 months. A hot plate would be 25,200, and a thermostatic bath, if you use that, just over 20,000. Now compare that again in terms of a fume cupboard for an Xelsius compared to the chiller requirement. I mean, again, you're looking at very much a fraction of that sort of thing, fraction of that energy savings as well. Now, this is based on 8 hours operation over 229 days. And we do appreciate that everyone's requirement is separate. So we do have a dedicated cost savings, energy savings, carbon footprint, that type of calculator. So, if anyone is interested, we can work out the numbers tailored to your process or based on what you do in your laboratory. In terms of the classic approach, as you can see, the total works out to be at 56,000 over a course of 12 months. That almost doubles over 24 months, and then obviously closer to tripling over a course of 36 months. Now compare that with the Xelsius and the numbers we get. There is actually already an 86% reduction in energy consumption compared to the classic approach. Compare that in terms of your carbon footprint over a course of 12 months is 12.19 tons. Compare that to with Xelsius, again, is 1.8 tons. So when you work out the calculations, we're saving just over 11 tons of CO2 per year. Now compare that with everything, with all the greener technology we can offer to you, and that's a significant saving for your laboratory, just purely on a greener side of things. Compare that to the costs. The 12 months cost is 28,000 over a period of 12 months for classic approach. Compare that to the Xelsius is 3,800, and again that gives us a saving of just over 24,000 per year. So as you can see, the return on investment in terms of the Xelsius instrument compared to the classic approach can be as little as sort of 12 to 24 months period, depending on your usage and what you're looking to do. Added to that, there is also the benefit of the carbon footprint, the savings, but also the application flexibility as well, where it might take a reaction approximately 3 to 4 hours on a heating plate or stirrers or anything like that. With the Xelsius and its faster heating rate, you might be able to perform that in as little as 20-30 minutes, depending on what you're looking to do, of course. This brings us to the summary in terms of what is actually the Xelsius. So, of course, you've got the innovation in terms of a very precise temperature-controlled reaction workstation. It's flexible and it's future-proofing your lab. It significantly reduces your laboratory footprint, energy consumption, carbon footprint, and of course the running cost as well. We are now at the end of the presentation, so I'd like to thank you for listening, and I'll hand over back to Duncan, to see if we've got any questions throughout the presentation.
Okay, thanks very much for Annika. That was great. We have had a few questions come in for you. The first one is, can one controller control more than one block of reactors?
Sure. So, I mean, I assume that that question probably relates to, as there were two modules. One module is dedicated for the reactor cells, so there is 10 in one. The second module is the PC hub. So I assume that that question is directed as to, can that one PC hub module control essentially 20? The answer to that is no. And the main reason for that is each line of the cells is linked to a line of electronic modules and its own controller on the PC hub. So essentially, you need one hub for 10 reactor cells. So unfortunately, at the moment, you can't. Never know in the future. Maybe something we can improve on.
Okay, great, thank you. Another one here. How many temperature ramps can you set?
Sure. So, I mean, in temperature ramps, there is actually that particular question can be answered in two ways, because essentially we've got two versions of the software. The first version and the very vague screen that you saw on my presentation slide, that's for our lab mode. So as you can see that within there is one profile, which is start, ramp, hold, cool, that way. Obviously, you can repeat that cycle as many times as you wish to do so. However, there is also a second version of the software, which is the Pro mode. And in the Pro mode, that particular profile can be set into multiple numbers. So there are two ways you can do it. It's very much tailored to your application.
Okay, fab. Is there an option for pressure? I'm guessing.
Yes, yes.
Vessels.
Like I said, yeah, thank you. Yeah, yes, there is option for pressure. I mean, we are currently already working on the pressure vessels, and it will be released in due course. So yes, the answer to that, in the near future, we can.
Okay, fantastic. One more, probably a very quick one for you. Is it possible to trial the instrument at site?
Yes, we do offer on-site demonstrations. We do have a relevant team who looks after this. So if you are interested in on-site demonstrations, that would be great. You know, we can obviously liaise with yourselves, organize the logistics, and to add to that, there is no cost involved for you. We manage the logistics. We send the system out. Our team member would come out there, show you on how to use the system. You can trial it, do different applications, and you know, hopefully we can receive some really positive feedback.
We've got some more specific ones for applications, but we'll maybe answer those offline individually. What we will do though, if anyone wants to share this webinar with colleagues or to have a copy of it, if you just contact your local representative, whether it's Annika, myself, or Ellis, we can send out a copy of the webinar or a link for the webinar so you can watch it offline. Other than that, that's going to conclude today's webinar. So thank you, Annika, for presenting. Thank you, everybody, for attending. And we will be in touch. Thank you very much.
Thank you very much.
Bye.